Would you like to start reconstructing virtual models yourself using photos or videos? Or do you need a few practical tips and tricks? Then you've come to the right place. A typical example of a multicopter is the DJI Mini 2, which at 249 grams is a real lightweight. There is a camera underneath the Mini 2, which can be aligned either forwards or gradually downwards. Let's start with the first question. Do you know the two different variants for automatic recording with multicopters? We first distinguish between recordings in which the camera looks directly downwards. We call these orthogonal flights in the following. Here, we often only aim to capture a so-called 2.5-dimensional model and not really a 3D model. This is because we only see everything from above. In the second variant, we angle the camera and try to look angled downwards or even from the side at target objects. This variant requires more effort, more time, and provides significantly more data. The aim here is to derive a 3D model from the data. Okay, we will now get to know the three most important categories of recording strategies from automatic flights. First, let's start with category 1, the orthogonal grid flights. During orthogonal flights, the camera looks directly downwards, and depending on the planned ground resolution, height, and image overlap, flies corresponding parallel flights at a calculated distance. It does not matter whether the multicopter flies forwards or backwards. This recording strategy is the simplest, and we can record large areas very quickly. If time is available, we can use image data redundancy and a parallel strategy to secure the survey. To do this, the area is flown over again in the direction rotated by 90 degrees. This procedure is also favorable for the internal algorithms, as intersection points can significantly improve the accuracy of the model. Furthermore, we are not as affected by disturbances such as wind. The calculation of the flight routes is completely automatic. As an example of orthogonal grid flights, I would like to show you our unofficial world record from 2018. In a team of 5 people and 2 DJI Phantom 4 multicopters, we recorded over 50 square kilometers in just 1 week in the Mongolian steppe. It was a hard piece of work, and perhaps I'll report on how this can be achieved later. However, in order to cover as large an area as possible, we use the simple grid flights here. We can see an example of one of the flights. The 42 square kilometers that we recorded in the Orkhon Valley could later be seamlessly added to an existing LiDAR dataset. This data made it possible to completely map the former capital of the Uyghurs at the end of the 9th century. Now let's see how we can use this recording pattern for examples from close-range photogrammetry. We can hopefully recognize the strategy here in the recording of the Toro Farnese. A smartphone video was recorded and the relevant individual images selected out of it. Next to it we see 2 simple grid recordings, one from top to bottom and one from left to right. In videogrammetry in particular, it is important that we provide the algorithms with many intersection points in order to better derive the camera model due to the often poorer optics. On the right, we can see the result of this short sequence with a total of 291 individual images calculated in reality capture. Let's move on to the second of the 3 basic categories of recording strategies. Now we are going to look at the oriented grid flights. If we angle the camera in one direction, it is usually an extended view forwards in the direction of flight of the multicopter. This means that we have to start the flight earlier, as the field of view is now offset in front of us. We have also only seen everything from one side and need a return flight that is only half the original distance and have to turn the multicopter. In order to see all 4 sides, we need the same shot offset by 90 degrees. This means that the effort required for the recording alone has quadrupled. As the algorithms do not have a linear runtime, which doubles the number of images and takes more than twice as long, we have to be prepared for a longer calculation. As an example of an automated oriented double grid flight, I would like to take another example from Mongolia. Here we see the remains of the palace city of the Uyghur Empire in the heart of the Orkhon Valley. Although the size of the area is comparable to the example in the steppe, we have 1,145 images here instead of 239. But the result speaks for itself. Even the filigree walls of the fortress can be recognized in great detail in the model. Let's see how we can use this recording strategy again for examples from close-range photogrammetry. The example does not show a pure form of oriented grid strategy. I don't have a practical example of that here, but this part of the Toro Farnese, which is in the Leipzig collection, is partly suitable for this. There are filigree 3D structures, some of which are only clearly visible from the side. In the pose estimation, however, you can clearly see the double grid strategy used. Now we come to the third and last of the three basic categories of recording strategies. Let's take a look at circle and helix flights. A circle flight is not very easy to fly manually and requires some practice and experience. It is one of the most important recording flights as it can record a central object, for example a building, from all sides and at a slightly equal distance. In a circle flight, we maintain altitude and fly once around the object, usually with the camera at a slight angle, to record the context in addition to the object. In a helix flight, which is the highest art form of recording, we circle continuously around the object but increase our height slightly. The camera must also tilt the angle slightly. Alternatively, circle flights can be flown at different heights and camera angles. The helix flight is part of the repertoire of the archaeocopter training that we offer. I am very pleased to show a project from the Sudbury Digital Imaging Working Group. It shows the Bredon Church in Leicestershire in England. David Moore recorded a 1-minute video with a DJI Mini 3 using a circle flight. The images were then automatically selected with J-keyframer and processed in Agisoft Metashape. The model can already be seen on Sketchfab. I am sure that this recording strategy is one of the first if you are dealing with close-range photogrammetry. It is the most natural way to capture models on a table. As an example, I would like to show a stone bowl from the Erdene Zoo Monastery in Mongolia. We can clearly see the shooting strategy used in the form of a helix. It is important here to observe the rule of 3 and to pay attention to special features of the object. Here, for example, there was a hole running through it, which was specially studied with the camera. Let's summarize briefly. We can learn a lot from the automated recording strategies used in aerial surveys. We also know the difference between orthogonal and oriented recordings, and we now know the three basic categories of imaging strategies and can adapt them to close-range photogrammetry.